Just quickly, the freeze drying process can be divided into 3 sections. Basically, the freezing step here at the beginning, the primary drying step. This is the actual sublimation phase where we remove the solvent, the frozen solvent, by sublimation, and the secondary drying step where we remove bound water, trapped water in the product by a short secondary drying step. There's no sublimation going on in this phase anymore. And this slide here highlights the phases in terms of liquid in a vial, frozen dark blue, and here it's indicated that the product dries, so sublimates. This is the core of ice. This is already dried product, but still with a lot of moisture. And you can see here a temperature probe already positioned in that vial, and this is what we will talk about. This is our key topic for today, product temperature measurement, and how we can achieve that product temperature measurement, or can technically realize product temperature measurement. So this slide quickly illustrates product defects, which again ultimately lead to some compromises in product quality. Compromises can be, for example, just appearance. That means cosmetic defects. Cosmetic defect would be, for example, a crown formation, which is highlighted here in this picture. The crown is basically here a solid part of residue of product which sticks at the vial wall, and the rest of the cake kind of shrinks and volume contracts, and therefore this part here stays as a very hard product, as a very solid product at the vial wall. And the problem is basically, once you want to reconstitute your product after, let's say, 2 to 3 years, this part here might not reconstitute quickly. And you get into problem with, for example, full reconstitution. That means you might see particles or incomplete reconstitution. Another factor is, for example, meltback or collapse. So the first bullet point, meltback. Meltback is related to being too early in your change from primary into secondary drying conditions. Once ice is left in your product during primary drying, once your endpoint determination of primary drying is not, let's say, is imperfect, is not appropriate by whatever technology determined, you might ramp into secondary drying. There's ice left, and this ice simply melts, and you create holes and product defects in your cake. More frequently, you will see micro collapse effect, shrinkage effects, or even collapse effect, collapse products. Here in this picture B, it's a collapse cake. It's not really a cake anymore. It's just very highly viscous product which sticks to the bottom of the vial, and it's tremendous effort to get this reconstituted. Even stability is questionable after a certain period of time. So in essence, impact on quality, these product defects. Pharmaceutical relevance, yes, we see prolonged reconstitution times for products having product defects. Impaired dose uniformity is an issue, and we have elevated residual moisture content in some of the cakes of a batch, and that moisture can impact, at the end of the day, your stability profile, chemical stability of a small molecule API or even a biopharmaceutical.